Remote sensing, that's the topic of Module 5, and where would modern meteorology be without remote sensing? But you might be asking, what the heck does remote sensing mean? Well, have you ever heard the expression, you don't have the remotest idea of what you're talking about? I get that a lot, actually. That essentially means that you don't have a clue, that you are somehow removed from the truth of the matter. Or how about the remote control of your television? What does that do? It allows you to change channels or turn up the volume without actually touching the television. The term remote sensing also means removed or apart. So what does remote sensing mean in terms of meteorology? Essentially, rather than sticking a thermometer in the ocean to gauge the temperature, often satellites orbiting the Earth are used to determine ocean temperature. That's an example of remote sensing. Of course, satellites shouldn't have all the fun. It is possible to take water temperature measurements directly, such as with buoys. You can get information about the atmosphere by sending up weather balloons with weather equipment, actually called a radiosonde, that determines the humidity, the temperature, the wind speed, the direction at different levels of the atmosphere. And in a similar way, radiosondes are dropped by hurricane hunter aircraft into hurricanes to learn about the structure of the storm. These are all considered to be in situ measurements as opposed to remote measurements. And this ground truth is often valuable in calibrating and testing the operation of remote sensors. But for the most part, in this module, we'll be dealing with remote sensors. So most remote sensors, whether it's space satellites or ground-based radar systems, all of them involve the measurement of electromagnetic radiation in a narrow region of the electromagnetic spectrum. Now, in a passive remote sensor, there's two different types, passive and active. In a passive remote sensor, the radiation originates from the measured object itself and is detected by the sensor. Cloud tops, for example, are cold, but even though they are cold, they still emit infrared radiation, which can be detected by an orbiting satellite. This would be considered a passive sensor because it is only receiving radiation, it's not emitting it. A Doppler radar system, on the other hand, is an active sensing system because it actually sends out pulses of radiation which are then reflected by rain droplets or ice within a storm, and those echo back to the radar site. So the radar, an active system, both transmits and receives the electromagnetic radiation, and actually it's microwaves in the case of radar. Now, having remote observations from radar and satellite has been an absolute boon for weather forecasters. It has revolutionized weather forecasting. However, it does take work on the part of a meteorologist to learn how to make the most of different satellite images. And those include visible, infrared, and water vapor imagery. Those are the most common in meteorology. Remote sensing can be a very powerful tool for measuring things in our vast atmosphere, but we need to be careful. I think you should pay particular attention to the table on page 183, which gives some useful guidelines for interpreting clouds on satellite imagery. And of course, the chapter concludes with details about other remote sensing equipment, such as Doppler radars and wind profilers. In any of these cases, in order to get the most out of any of these observations, we need to first understand how the remotely sensed measurement was collected and what it means, as well as what it doesn't mean. Secondly, we must use the right tool for the right measurement. And third, we must be careful in situations where the instrument may not be correctly measuring what is really going on.